Hello. Today we're talking about event modeling and refactoring primarily. I try to do these with as little agenda as possible so that we can ad lib in case we get some streamer viewer participation. So in case you're in chat on LinkedIn, in case you're in chat on YouTube, hello. Say hello. Let yourself be known. If we're doing any kind of coding today, if we're doing refactoring, I'll probably be doing live on a kata. So let's check out who's with us. Hello. I'll grab some materials in the meantime because I just came off of a great conversation for another podcast that I'll be announcing at a later point. And we spoke a lot about event modeling, and it got my creativity boosted. So happy to continue the conversation about event modeling. Let's see, nobody's in right now. Let's see, does it work everywhere? We're gonna do a sanity check. 1 2 1 2 1 2. Are we live? Yes, we're live. Do I need to listen to myself? No, I don't. Okay, that works. LinkedIn is reporting in, and everything seems to be okay. Let's see. What I did want to share specifically for today is event modeling, and I would like to share a little bit of a present screen. Do I want to share everything? Maybe. No, I don't want to share everything. I want to share this. That works. Let me take the background off, eh? How about we take the background off and go to bubbles? Yeah, that works. So basically, what I have open here is the event modeling website. One of the things I want to start off with a conversation is the cheat sheet. It's quite a good cheat sheet. We can open it up. You can look at it from this. Yes, very good. So it's a little bit bigger. All right. Yes, that's what we want. All right, cool. What else? Okay. Yes, and the original post from Adam. And yes, I want this one as well. Awesome. So I often get asked the question, what is event modeling? A lot of people, even me included, on my sort of version 1 understanding of what event modeling is, it generally landed on it's kind of like event storming and it has something to do with events. So in my mind, I thought there was always the equivalent of a like an open API spec, or is that a glitch on my screen? That's weird. Okay. For me, it was always this combination of, is it an open API spec just for event-driven APIs, or what's the deal? Like, why do I need events and commands separated like this? What's the benefit really of having it be managed this way? And then it turned out, as it turns out, the real benefit to talking about event modeling in this context is that it's a project management tool. And that I only learned after speaking with Adam Dimitruk, the inventor, or the person who the discoverer of event modeling. So what it is essentially, it's a diagram that looks like this. It's very simple. It has a few elements that we can go through right now. Specifically, it starts off with events, which are the orange boxes. And if you want a little cheat sheet, blue boxes go to orange boxes go to green boxes go to UI or automation, and the user uses the UI to make blue boxes, and automation just uses whatever they are doing to create blue boxes. That's a really easy way of thinking about event modeling. That's the entire flow regarding the arrows. It's even in the legend at the bottom left here. But it is your first time dealing with event modeling, it might not be obvious that this is actually very important. So what it is, can I scribble? No, I can't. Okay. What's really important regarding event modeling is that it's not a document that you'll be using a lot with your engineers. Event modeling is the most useful if you're using it instead of a project management tool. So rather than having a spec, because usually what happens is you create a spec. And hang on, I might need to. Yes, I need to reset this. Usually what happens is you might have a spec, and with the spec, you say, okay, here's some business requirements that we use to create the specs. And now we sort of need to figure out how this translates. This is like this is a business problem, and it needs to translate over to an engineering problem. And there is something in between here that translates them. And usually this is where a lot of teams get super confused. It's like, who should do this? Is this an architect's job? Is this the team leader's job? Especially if the business requirements for a tech product, like a software as a service company, if you have a head of product defining the business requirements, but then they don't know how to make the technical spec, the technical spec might also require decisions to be made while creating the spec. So it's not as if you're just documenting it and converting it from one document to the other. What actually happens is that while you're writing the spec, you end up either discovering or creating new business requirements. And this is very typical. If I use database A, then we can't do X. If I use database B, then we can't use Y. If I shard the database this way, this will have a downstream consequence for all of our users in this manner, right? So usually when you're creating a spec, it has upstream consequences. I mean, you're defining the business requirements, they have downstream consequences to the engineering team. And this loop here, is already a signal that these things should never be two separate documents. If you're planning a project using these documents, in sort of like a waterfall model or like a double looped agile model, when let's say this is the product. This is the product lifecycle, and this thing here has an engineering lifecycle, for example, right? And the engineering lifecycle basically is, was the spec correct? Did the engineer end up making decisions? Because the engineer does the same thing as well. While the team is implementing it, they might find things that cannot be done according to the plan, and they might have to define nuance, or somebody might decide, oh, hey, when we're defining the API, it turns out that it's a lot easier if I pass this and that information with the initial request so that we can load a page faster, and I will make that change now, and then I'll backlog that into the spec, but the spec might have been created by a business requirement, so now this goes upstream as a little green arrow to blue arrow, like a little non-functional requirement that has a positive performance impact. but it doesn't make it back into that language. So what event modeling allows you, and again, this is a sign that this process shouldn't have 3 separate documents maintaining a sort of lifecycle flow. This black arrow might be Jira, and then this green arrow might be this second black arrow might be something like continuous delivery or just release planning, continuous integration, etc. Whatever floats your boat. And this already gives you a big idea that regardless of where you are on this flow, everything is a product decision. The business analyst who makes a decision, that's a product decision. The person making the spec and then putting it into Jira and then deciding how to split the stories, that's a product decision. And the engineer who is deciding how to, are we shadow launching this? Am I going to feature flag this? Is it going to be an abstraction? That's another product decision. It might be on a different sort of blast radius, right? The engineer who's building a simple class, the blast radius might be very narrow. They're working at a very sort of zoomed in cadence. Whereas the engineer who might be a leader at this point, or maybe it's a VP of engineering and VP of product, working together to flesh out the business requirements on the top, the product lifecycle, they might be dealing with it. The same problem, but from a different zoom level. It all ends up being just product decisions. So this is your typical project. And a lot of teams I see deal with this problem in a sort of agile, Scrum, false Scrum, fail at water. What is it? Water Scrum, Scrum fall. Like all these weird. We are using Scrum, but not really, or we're doing something of our own based on agile, like whatever. What event modeling is setting out to do is create a single document. Right, so in this example, we might have 3 different documents with 3 different zoom levels. What event modeling is trying to do, especially if you're building this event model with a Miro board, is to get all of these 3 levels of decisions onto the same board. And whereas a traditional project planning methodology might be using the team's, let's say, focus as an element that moves to the system. It's like I have this ticket. I want to be notified when the team's focus reaches this system, and then the team's focus goes somewhere else. And then the ticket is joining the team's focus. If I gamify it and if I make the team's focus the water, then the sprint plan and the Jira or whatever other software you're using, that is essentially the pipes. So somebody who's managing the project is setting out how the pipes are set up, and the team is just flowing through that, ideally. Whereas with event modeling, if you want to use it as a project management system, what you can do here is set up instead of having the pipes, which are, let's say, synthetically made up, they're synthetic based on somebody's idea of how the organization moves or what an iteration is. Instead, we say, this is the life cycle of data in our system, and our system will be doing 3 different things, essentially. It'll gather or signal user input. It'll modify data, or it'll just do raw compute. Right, so the blue to orange arrow, that's the modification of data. Like we are changing the contents of the database. We're creating new information. Whereas the orange to green system, we are just computing that information. We might still temporarily store it, but in essence, it is performing compute. And you can see where I'm going with this, is that if you follow the arrows, according to the bottom left legend, you will come up with a system that is, regardless of which event type you're starting at, you have essentially a completely isolated, side effect-free black box. The only side effects that are inside the system are those that pass in the above layer where the white boxes are, the UI and automation. So even something like a checkout processor, like a payment processor, those are beyond our system. And we track that as side effects that we do not control. So if even just looking at this model like a maybe functional programming, like a declarative programming style, what's below the line, this line here, what's below this line is defining the software that we need to create and maintain. Whereas above the line, there's either external automation or UIs or UX or maybe some UI elements that are automated or not automated. But you can see that any kind of UI element that is being created above the line follows a slightly different paradigm than we are doing here. And that might be a mobile app and it has a completely different project management structure. It might be a completely separate website. Or it can be part of this website. And we're actually event modeling the sort of front end level, the middleware level, stores and business logic in the event model as well. And then we're just using the white pictures, the UX and the wireframes as means of abstracting that exchange of information. Often the various offline aspects and web worker aspects of modern single-page applications are essentially a completely separate application from the API itself. And I see a lot of teams even implement this, with the T3 stack perhaps being a notable exception, where they try to merge together a sort of server-side rendered single-page application backend engine in TypeScript with a front-end engine in TypeScript, and they're sort of trying to blur that this line exists. I don't have much experience with it, but I saw similar attempts in the past, in the late 2000s, and I wasn't impressed by it. The technology simply wasn't there. But, that's a different story. So here, what I want to mention primarily is you can use this as a project management tool by planning your work based on the types of transformations that you need to perform with data. So all the sort of important business events, we're not really using terminology from the database or your architecture or your stack. That might happen. I would encourage you, if you're using a Miro board, to draw this, to actually, go into technical detail, like specifying endpoints and going into more granular detail about the schema, about certain data types and elements, by creating a subframe or a frame in Miro and only exposing that if you zoom into the diagram. I even saw that automated to a very, very good degree on a piece of software called Proofboard, I believe it's called. I'm going to open it up here. Haven't used it yet because there's a whole pricing thing going on and I haven't had much luck with it. But as you can see, this is the overall idea. You want to be able to say, okay, these are the important features. The downstream consequence of what we want to establish are sales reports and payments, and those are the things we care about. And there's no sales reports and payments if the checkout isn't working. So perhaps what we might, sorry, this is a booking system. and there are no sales reports if there's no bookings, you might want to say, okay, start the project at the far left at the youngest data, right? Because the registration would be the oldest data, because on the left side, the data points would be the ones that are created first in your system. And then you would model your project based on the flow of data left to right. And that's a huge mistake, because the main revenue enablers and the value stream providers to your business are left is identity management. The far right here with the sales reports, that is usually business analytics. Those two extremes can be commoditized and built with off-the-shelf software. What defines your business is this little chunk here in the middle, leaning slightly towards the right. And if you can figure out which of these chunks to automate or use with or implement with off-the-shelf software, well, then you know, if you zoom in, then you know which events, which chunks communicate with the other chunks by their data dependencies. It's like, oh, when I update this event here in room booked, it updates the cleaning schedule projection in the ready room, in the readying the room process. And I can see that a person can only check in. You can't see this error, right? That's weird. You can see. Oh, okay. You can see it. Yeah. Where is it? Yes. There. Oh, that's the timeline. Okay. And you can see that the whole idea of checking in and having automatic check-in and doing payments, there are certain dependencies in between the layers. And it's those overlaps. It's where those different contexts overlap and go from one to the other. That's where the most complexity lives. It's like, hey, can this fail? Is there a message queue in between there? Is this independently deployed? Is this a giant monolith? If this is a giant monolith, is this action in the same transaction as this one? Is that complicated to do? Does this command, if this command creates a side effect and updates this thing, does that happen in the command processor of check-in? Do I have enough context there? Is it appropriate to have context there? What consequence is there for scaling that? So already you can see there's a lot of easy compromises that you can do on a project management level, which are really not technical questions. They are technically motivated in that it's the engineer who first discovers that the decision hasn't been made yet, but usually it's not a technical problem. You might have problems like, well, then is what happens if there's a race condition and two people check in and book the same room at the same time. But that's not a technical problem. It's a business problem. That can also happen on airplanes. And the airplane needs to decide what to do. Should they rebook? Should they refund? What happens if this is determined only 5 minutes before the plane is about to leave? If you don't do mandatory check-ins before arriving at the airport, then you'll only discover this problem as the two people who are booked into the same seat on the airplane are checking into the flight at the gate, right? So there has to be a business policy for making sure what happens when there's conflicts. And again, a lot of these kind of technical decisions are usually product depth, not really technical depth. Technical depth is when you start making spaghetti code and you're not really making bad code on purpose, but you just under prioritize refactoring. But let's stay on event modeling for a while longer. If you're a project manager, you will sort of see the sub-k-ness, so the level just below the UI, that's usually that really dark and murky backend stuff that happens in the middle of the, like in the most important part of the project. That you will be able to visualize, like how does it impact communication flow? Because what a lot of teams, well, what I find a lot of teams leave on the table is they will start this project, and then version 1 will be a implementation of everything on the board left to right. That will be the first deploy. With a very inexperienced team, they look at the spec and it's like, okay, yeah, that's what we need to do. Or God forbid, an agency, they do this entire board and then they implement it, and then there's launch day or test day, and then there's a huge amount of problems, huge amount of unanswered questions like, hey, I clicked this and then that happened. Is that expected? Is that not expected? And then someone might say, well, I don't know. It's not in the spec. What should happen? And then at that point, it's probably too late. You might discover you have to refactor something, etc., etc. What an experienced team will do, especially one that is using an event model, is they might say, okay, this is my data flow for automatic checkout. That's pretty cool, but this hotel proximity thing, I don't think is necessary for. I don't think it's necessary for an MVP, let's say. What I do need is I do need a guest roster in order to build them and then check out. And I do need some kind of check-in terminal to check in. And I'm assuming I'm doing that by booking a room when the room is ready. Everything else I will fake. I will fake the guest registration. I will fake the adding of rooms. I'll maybe make it static. I will fake the room availability. I will fake the cleaning schedule. I might just make it a static PDF. You might, because you have vertical slices for everything. You have a state view, a state change view. And you might say, well, the most complicated thing is the biggest box, which are these two. So you might decide that, hey, you know what? I want to build these two first. Or if this is silly, I might want to do the most important one, which is the revenue enabling one, which is this one. Right, so I'm going to do registered room, added book room, room booked. This flow is really important to me. This is what I'm going to do first. And then in parallel, payment succeeded, and then creating a sales report based on that. That's my number 2. But this is incomplete. Like you can see here that this event model, I used as an example on proof board, is incomplete because I got to the state change, and this room booked event would need to have a green projection updated, and you can probably see it. Yes, you see, room booked updates the cleaning schedule. But then this probably has a downstream consequence as well on the ready room and the reservations, right? So what I'm missing here is a projection for reservations and when which room is booked. That's definitely standing out as something that is incomplete to this model. But this is one of many examples of what you can do in order to. This is using the same. This is using the same example. This is one of those examples that you can use to highlight and expose gaps in your understanding of what to build and how to build it, and specifically how to build it, but on that sort of overlap of, it just went from business to product and product to engineering, and in translation there were some nuances that were missing, but we couldn't see it from the top. Like it can only be visible from an engineer's perspective. So hello, thank you for joining. Just explaining event modeling. Thank you for joining, Gandhi. So my understanding of event modeling evolved when I started looking at this like a project plan. No, thank you, brother. Sending you greetings from the cool and quite pleasantly mild Slovenia. We had some thunderstorms lately, which reminded me of monsoon weather. But it's definitely a a nice refresher compared to the 40 degrees heat that we had last week. If you have any questions, let me know. I will be sort of changing gears a bit and changing to refactoring in a bit. No, I'm not. I do. So my understanding of event modeling evolved when I started looking at it like a project management tool. Because really the important thing about event modeling that I miss, the detail that I miss from things like Jira and having story points and story tickets and stories and epics from Jira, is that there is no clear release plan from that. They might have acceptance criteria. Like really good teams will have acceptance criteria. They will have like a plan for this goes into that version. But usually that happens after the fact. What I'm missing is usually what I call tactical agility, is when somebody says, you know what, I need this UI first. Like this is the history of the data flow, how the data will flow from left to right. And in order for us to check market viability for a certain feature or for a certain subsystem in a product, I need the UI deployed and sort of I need to be able to click it. I need to be able to interact with the UI. I need to be able to show it to somebody, and it needs to not crash. So the equivalent of doing a demo on fake data, and then you go from fake data to real data, and you might be faking the UI and you make it a real UI, and you go from static account or static demo account to a real user registration flow, and then maybe if this is fintech, then further on to KYC and user confirmation, and then address checks. And upstream to the organization, you might say, hey, there's these like race conditions here, and then these exotic scenarios where the user can do this and this and this. How important is this to incorporate into the system? And the event model, whenever you find gaps, for example, what was it? One of the gaps we found is that once you have a room booked and it's ready and you're about to check in, it might be useful to know which rooms are booked when and update one of it. I'm missing a green projection here for room availability. I think room booked should also affect room availability. I think that's an oversight here on this example. You can see this, right? The room added creates the room, makes it available, but then when you book it, they should also have a projection update on room availability. But obviously, it's just an example. But to me, this was easy to find because when I'm looking at the projections, I'm thinking, well, no, hang on. Availability is computed by adding rooms and by booking rooms and by somebody checking out of the room or checking into the room. So that's definitely missing on the event model. I can easily find that. If I was looking at a Google document that is a spec, and then there would have to be some process flow of database schemas and entity relationship diagrams, this might just go under the radar until an engineer starts implementing it and they hit a wall. So in order to really squeeze out some extra productivity from your team, what you can do is you can put up this. Essentially, the plan is the entire life cycle of data around which your app is being created. And you can decide to start from the right side. You can decide, okay, you know what, I don't have anything to report on sales unless I make payments. In order to make payments, there needs to be something that we are paying, and paying happens either at booking or checking out. Again, that connection is missing. So just by looking at the diagram, I can tell, okay, this is a business, we want to make a profit. To check my profit, I will have a sales report. And in order for this feature to generate sales, I need those two UIs to be functioning. Those two UIs need these projections and these commands. And then I need all derivative sort of side effects of how those change and how those are created along the way. And I'm just going to start with the UI and fake the immediate neighbors, right? So you might say, okay, just start with the sales report. just give me fake data here, and then give me a checkout processor, just have a fake roster, and then give me a fake room availability, just hard code something, and help me simulate the booking room flow. You might be able to do that week one or even day one, instead of creating a fully end-to-end integrated system. Usually a team spends so much time configuring their ORM, their project, their initial schema, testing out whether the database migrations survived the initial checks, setting up the entire project, that they might not even consider that if you just fake the data and started with some tests, that if you just hosted everything on a single node, a compute node with some local SQLite database, then you might actually be able to just hook up the fake designs or the UX wireframes that you have and test the flow and just click through it. That might already be useful to someone. If nothing else, you can set it up as a precursor to testing your deployment pipeline, setting up a coming soon page or people who want bookings, and you can just say, hey, there's no rooms available right now. Sign up for our waiting list. That might be version 1. From a product perspective, that might already be useful. And it might already be touching the real data points. Okay, so when there's a room available, that booking page goes from waiting list to actually booking. Again, those are things that you can discover just by looking at this diagram and then making sure that left to right is consistent, and by having somebody who is business savvy on this call, because this diagram has no technical jargon, unless you zoom in and you start adding detail, they might be able to just say and add flow to this. Because typically if this was an Airbnb booking app, obviously what you would also need here that's missing is, when you add a room, there might be more detail than you can fit into a single command, like updating images and having screenshots and having amenities listed and reviews, etc. Right? There's no review flow here, so that's definitely incomplete for the business. But that you might already extract and determine from the event model. Any questions in chat regarding event modeling so far? So to recap really quickly, what I found was event modeling isn't so much about planning your events and planning out what you want to build. Event modeling is much more useful if you think about it as a project management tool. Project management tools, where is the hard stuff? And usually the hard stuff is about transforming some piece of data and synchronizing it with some other source, and then sending it across this line to some external processor, and maybe there's some integration going on there. All right, so you already know that is where you'll have the most need for specialized engineering skill that also overlaps with business understanding. And the immediate benefits of using event modeling is that, unlike traditional project management methodologies that would have you sort of plan out this entire system and then go left to right in the timeline, following the timeline of the data points, you might decide that, hey, you know what? This thing here where you're checking in and checking out, those are the most important pieces of my... no, that's not what I wanted to do. Those are the most important pieces of my structure. I'm just going to focus on this vertical slice, this one, and then everything else I'll fake. So I'll just set up a static project, put that one in, put the other one in, boom. Real data between check in and check out, and fake data preceding and following up on that. And that might be a very pragmatic prototype or even just an MVP for version 1. Okay. Let's see, are there any questions here? Are we connected on LinkedIn? Let's see. Are we live on LinkedIn? We are. Okay. Everything good. Okay. Cool. So let's change gears a bit and let's jump over to refactoring. And I like refactoring with I like refactoring with what's it called? Gilded Rose. What are we doing? Oh, is it on CyberDojo? No, it's not. Oh, is it? No, it's not. Oh, that sucks. Okay. So let's go. What is it? TypeScript? Is it capital T? Of course. So for those of you that don't know, Gilded Rose. Gilded Rose is a typical example of code that is, let's say, production ready, but where the team has neglected refactoring. And what it's incentivizing you to do is to refactor before you add a new feature, and then it's asking you to add a new item type, right? So what we're having is we essentially have messy code, and what the instructions for the kata are is adding. There we go. Is it denotes what the rules for the game are. It sets some rules for what we're not allowed to change, and it wants us to refactor this and then add conjured items. I don't think I'll have enough time today to explain all the concepts that arrive here. I would like to, however, explain where a lot of people go wrong doing this kata. So this project has tests already, and it has a working implementation. And what's really important to keep in mind is that, wait, was that an actual to-do? Yes, that's an actual to-do. Is that if you add tests to this, I believe this is the original. Yes, this is the original sort of end-to-end test, like just going through it. It wants to check if it's working correctly. What the app wants you to do is just write tests, refactor using those tests, and then add new functionality. And where a lot of engineers already go wrong from the get-go is that they look at this and they start looking for bugs. It's like, oh, this is wrong, and this is wrong, and this is wrong, and this is wrong, or maybe, oh no, there's a mistake. The requirements don't say this or that, or don't claim this, or the requirements are, God forbid, inconsistent, or there's something that's inconsistent, like the sulfurous. Like, why does it, like, how should we update quality? It always has 50 quality. Is it are we gonna adapt this with polymorphism? Are we going to adapt this by, is the problem that we're repeating this all the time? Is the problem that we're repeating this all the time? You can, if you already studied your code smells very well, you will notice the bumpy road code smell. You can tell there's unattended to refactoring and the code smell lurking in this code by just following the intensity of the indentation. And you'll notice that this one is what 7 levels deep, 8 levels deep, and the cyclomatic complexity of this file is, I think, 20. So it'll already give you a hint that there is something to improve here. And don't get me wrong, the code works. It's just that when a developer comes here and wants to add a new feature, because of how confusing it is, I might actually make it not work anymore. Right? So I might accidentally break stuff just because of how difficult it is to add a feature to the system. Because you might notice is that, quality, if I just look at assignments, space equals sign space, then quality, for example, is being assigned in many different places and with many different ways of assignment in a for loop for all items. And you can see that this is basically a rule engine. Spoilers, this is just a rule engine. The instructions tell us what should happen, and these are rules, and we're just basically following those rules. So that's already a hint that this can possibly be simplified. And I think the simplest Gilded Rose Kata implementations that I've seen in the wild are, I think, a few lines of code. So all of this usually what happens when I'm doing refactoring coaching sessions of this nature is that while refactoring, we'll actually increase the complexity of this file, because we will try not to modify the existing code. We'll just try to copy things out and refactor them and then slowly replace functionality. And then once tests still pass, we delete the old code, and then that last step is what really simplifies the entire process. What a lot of engineers get surprised by is that the functionality of what this thing is doing fits on, I think, 8 lines of code. You don't need more than that. Now that might not be obvious to you just by looking at this screen, but that's the whole point. Refactoring is about exposing how obvious it is what this is doing and how easy or how hard it is to change. Because this thing is very simple, but it is not written simply. So even though the requirements are easy to change, because the underlying requirements are simple, right? So if you have a non-technical person who has never seen this mess, they might say, oh, the requirements are simple. With the simple requirements we also have, I just want conjured items. The requirements we have right now are super simple. I can do this on a piece of paper. Please add just this requirement. How hard can it possibly be? I'm sure if you're working it, if you're professionally employed as a software engineer, I'm sure you've heard that before. It's like, how hard, from the perspective of the product person or from the non-technical business stakeholder, what they have in their mind is this. It's like, well, yeah, these are the requirements, and I'm just adding this thing. Like, how hard could it possibly be for you to do this? The problem is, if the engineer who encounters this is not the person who has written this, or if it is the same person and a lot of time has passed since the initial implementation, then what may happen is the current implementation, the understanding of it has been lost to such a degree that now somebody has to comb through this mess to figure out where to put the conjured items to not break the existing functionality, right? Because we're doing essentially, we're doing append-only requirements changes, right? Where we want the business to maintain the existing requirements and add another requirement on top of it. But a lot of engineers where I see them get stuck is that they then try to figure out, okay, well, they start analyzing this. It's like, okay, I probably only need to add one line of code, and it'll make this mess a bigger mess. I just need to know where to put it so that everything will be okay. And then they might say, okay, there's an if statement here, there's an if statement there, this is that if statement. If I put my conjured items here, then that definitely, I can just put it here. Boom, conjured item, then use the oh wait, what? Twice as fast as normal items. Okay, so where are normal items? And then you might Google, you might search normal item, and normal item doesn't show anymore. And then you might, the engineer who is now clueless and lost is looking for normal item because it's in the requirements. The requirement says, hey, conjured items degrade in quality twice as fast as normal items. And then you don't know which of these lines of code affects normal items. And that's where the trouble starts. Because then in your mind, you might say, okay, take the code for normal items, put an if statement for conjured items, put the normal item code in there and multiply it by 2. But even that is non-trivial because you don't know which of these pertains for a normal item. And there's a hint here already. It's like, oh, aged brie. It's not aged brie. It's not backstage passes, and it's not sulfurous. So these 3 if statements combined, is that a normal item? It's not this, not this, not this, and quality greater than 0. Oh, so maybe this is the normal item code. But you're already not sure. Which means that whoever is now building this, rather than having clarity, they are stumbling. And then they might realize that, oh, actually, this if statement closes here. And then there's another if statement that might, again, apply to conjured items. Right? Because we have the same if statement, not aged brie, not backstage, and not sulfurous. And quality greater than 0. You see how this if statement is exactly the same as this one? But it's not structured the same. And quality is being reduced one more time if the sell-in date is smaller than 0, right? So that's the additional condition. Because that's the condition where it says once the sell-by date has passed, quality degrades twice as fast. So we have this concept of quality degrades twice as fast once the sell-by date has passed. And we also say quality degrades twice as fast as a normal item if it's conjured. So you might say, well, hold on. If this thing's here, if this means sell-by date, if I just copy this piece of code and make it a conjured item, it might actually work. But because of how it is structured, this piece of the if statement was hijacked to hide another requirement, which is this one. No, sorry, it's which one was it? Quality is it'll increase so if it's aged brie, it'll increase. So if you just copy this piece of code and you apply it to conjured items, you'll have the copied piece of code for aged brie as well, as if it was a conjured aged brie, which I'm assuming doesn't increase 8 times as fast, but only twice as fast, because it's a conjured item, not because it's aged brie. So because it's not obvious, it's a simple business change, but it's not obvious to implement because of the method that was created. The kata will show you how to simplify the code so that you're not starting off, if I go to Excalidraw, you might be thinking as, okay, so this is my baseline feature. This is my baseline feature. I have I have the timeline, and this is complexity, or even just perhaps even just perceived complexity. Right, so it doesn't need to be complex. It just needs to be perceived as complex by virtue of, okay, I'm looking at this. This is really complicated. I've spent at least 15 minutes looking at this. What if it's actually much harder to do? The problem is when you actually want to do a simple change, which will increase complexity a little bit, but it takes a long time. That is what you want to avoid. Right, so the trade-off that we're trying to establish is that if this takes a long time and it increases complexity by a little bit, really what we're aiming for is we are trying to explain to the business why this change costs this much time, and we want to be able to communicate that with a high degree of confidence, right? Because the business knows that this level of complexity, something that was simpler to do, took less time. Sorry, something that was more complex to do took less time. Right? This is really complex, but it took this much time. And maybe it's not fair, right? Maybe it's something like this. Maybe it's something like this. But again, you can see this is very complex, takes this much time. And then what we're building here is essentially this, only this. So this is the green box plus the red box on top. It is much simpler on paper, but it might take us the equivalent of a fraction of what it might take for do a complete rewrite. This is where the fallacy for a lot of software engineers come from. It's like, oh, this is so complex. Like I spent so much time just staring at the screen that it would probably just be easier to rewrite it. And then they rewrite it, but they rewrite it by also including the new features, which are not documented yet, which are not fully understood yet, which are not test covered yet, and then they get stuck. And that is how most startups go out of money, because they constantly do complete rewrites of their software, because at some point they become so slow. This is the slowdown, right? Small complexity and seemingly comparable time gaps, right? So this is something very complex, which you did initially, which was very expensive, which took time t, and then this is now very simple, but it also takes time t because it is built on top of a mess caused by the original implementation that wasn't refactored. So if you never did the math on this, what you want to be considering for refactoring is that, or if your manager needs convincing that we should be refactoring more often, the chart that you can show them is that what we really want to do is that if this system just hides complexity, we can gradually refactor this so that it becomes less complex. And the refactoring is usually a very quick, very safe operation, unless you don't understand the system. And if you don't understand the system, what you're trading with is this, the red box, not the green box. So as long as this second box is smaller than this red box, you're good. You're net positive on investment. So what you want to do is you want to continuously refactor the system so that once you get here, there's no new features here. You just have, let's say, downtime, or there's a new feature coming. Rather than investing this amount of time, you invest this amount of time to refactor, and then you implement the feature very easily. Because once you're down here, the complexity has decreased, and now the feature is much simpler to implement, and now you've increased in complexity again. This is what you want to do, because you want to ensure to the business that not only do we understand where the complexity is going, but you want to make this arrow smaller than this arrow. But the added benefit is that if you do this again, the complexity will keep going down. You might have new features, but the complexity is continually going down. So the third and fourth and fifth iteration with the second engineering team, because the first one quit, once you get to the point where you need to add something really complex, it can easily be done still in the same fraction of time, because you're spending a little bit of time every time you touch it to refactor it. Whereas here, this box just keeps getting bigger and bigger and bigger. And the taller it gets, the more incrementally challenging this becomes. And usually this is where, eventually somebody asks for a small change and another small change and another small change. And then the business says, okay, now we need to do a big change, and then it becomes this. Then management asks you, okay, Dennis, how long does this take? And then they're dumbfounded when you tell them, you know what, it'll take us 2 years to implement this because we did zero investment. So this is the investment, this here, this, and this. We did zero investment to manage complexity by refactoring. So the complexity went up, which is now how we ended up here. Whereas if you continuously invest, then the complexity in an ideal world remains about the same. So about the same levels of complexity of increases take about the same amount of time. So that's the big why on why you would consider refactoring. The other thing is that when you're refactoring, what a lot of engineers get wrong, especially the ones that are starting to refactor from after their boot camps or after their studies, and then they are taught as engineers, from a sciencey perspective, that they need to design and plan up front, so that the initial design is perfect, and then the quality of their software is determined by their ability to follow the initial plan. That sort of waterfall kind of thinking, where we invest a lot of time into creating the perfect plan, which is big design up front, which is good if you're doing it, but the design needs to be big. You can't do small design up front and then sort of assume it'll all be perfect. So when that sort of big design up front mentality is there, but the design isn't there, the specs aren't picture perfect, and they have no test, they have no touch with reality until you build it, a lot of engineers get lost because they end up building. A lot of freshman engineers, junior engineers, mid-level engineers get lost in this weeds of, wait, hold on, I thought I would be using the latest technologies and Kubernetes and do functional programming with curried functions and left fold and use the latest algorithms that you guys have asked me on the interview questions. And now here's a big PHP monolith that sort of everybody's scared to touch. And then rather than being excited, they just get stressed out. And then what I see with coaching teams like that is that they have no toolkit for managing complexity, because they assume that the code that is there is necessary, right? So this is the aha moment that I like evoking the most in coaching sessions, is that when engineers see the before, which is this code, this might be a metaphor for a big ball of mud, a sort of monolith, and the after of this refactoring, only then do they get the aha moment that, oh, the complexity of the original implementation. So this, me reading this, what is this? 60 lines of code, and a giant monolith might be thousands or 10,000s or even millions of lines of code. To come to the realization that in order to fulfill all product requirements, that the complexity in implementation was unnecessary. It's like, oh, I thought we needed to maintain the complex implementation because it was for some reason part of the product. That somebody requested it to be this way. And that's the thing about refactoring. And that's also the thing about tests. When I see a lot of engineering teams build tests for systems like this, if they make very brittle tests, they might be actually testing word for word. It's like, hey, if the item is this, ensure that this if statement is called. If this is a more complex system, they might say, okay, so if I know there should be this if statement in here, so create a test scenario that tests whether that if statement is triggered. So when I refactor this, the test will fail even if the code still works. Those are. I had a podcast with Jason Gorman when he mentioned, that is the equivalent of having melted cheese stuck to a radio. Like, it might still work, but theirs is just a mess. Like, you can't clean it, you can't pull it apart, you can put it back together if you pull it apart. And everybody looking at that will assume that the melted cheese provides some functional requirement, not knowing that it is perfectly capable of performing in a clean state and possibly without most of the moving parts of the radio. So I will be talking more on refactoring on the crafting tech teams on the newsletter. And I'm also doing, with one of the teams I'm coaching right now, I'm also doing much more hands-on katas on refactoring. So I'll be able to share a little bit more insights on the sort of human elements of what happens during refactoring sessions. And I can recommend, if you don't have it yet, Refactoring Guru. This is from Martin Fowler's book Refactoring. This is a website that sort of captures the patterns of the book, the code smells that Martin and Kent Beck termed together. Where if you're new to refactoring and you want to figure out how to not lose your mind and create a big ball of mud accidentally, or if you're in one, my recommendation is learn how to spot code smells. So my challenge to you would be, look at this file and just name the code smells. Not fix it, not make it work, just name the code smells. Which code smells are here? If you can do that, you're on the right path. Because every code smell has an appropriate treatment, let's say. Every refactoring is a recipe of how to turn code smells into quality. Quality is created by refactoring a code smell. And I think that's the concepts that I see engineers dismiss or undervalue the most. Because usually most code that gets created by businesses, the businesses eventually come to hate because it provides business value. It was probably hacked together very quickly, and it is essentially in this category. It's a this kind of big ball of mud, of meh. It took a long time. It's very messy, and now it ended up looking like this, even though the requirements were simple. And now the business hates it, and the engineers hate working on it. But it provides revenue. It enables value on a revenue stream feature, on a feature that provides revenue to the business. And a lot of engineers dismiss this. Like, hey, can we throw this away? I want to work on a microservice Kubernetes greenfield project. But however, what they don't know how to do is how to turn this problem, this code smell, into that which they want to work on. How to turn this type of code into easy to understand, simple code. And that is, if you ask me, that is, along with architectural knowledge and soft skills, learning how to spot code smells and how to refactor them is by far the most underrated skill for designing high quality software. Because people can tell you, follow solid, follow dry, follow KISS, follow wet, follow LSP, follow clean code, clean architecture. What do I have here? Code Complete, the old Microsoft book. You can read all the books, and they will teach you how to craft clean code on a greenfield project. But they will never teach you how to deal with code where the original author did not do that. And Michael Feathers' book, Working Effectively with Legacy Applications, that really, Michael Feathers tackles that. And even Uncle Bob, when he wrote Clean Code, also tackles that, but particularly in the context of patterns and code smells, of how code smells expose a pattern to be exposed by refactoring. But really, it's this idea, and I saw Sandy Metz talk about this a lot. If you pull up Crafting Tech Teams, I spoke on this post, where if you just learn the code smells, and I urge you, if this is too complex, if checking out this file, and you can, if you don't know TypeScript, if you're a PHP developer, you can pull this up in PHP, because no matter what I show you, it's always more ugly in PHP. If you pull this up, if you can just name the code smells, if you can just name the category of code smells, right? These are the categories, 1, 2, 3, 4, 5. You'll be much better than 99% of the engineers that you're competing against at your level. Because then once you know what the code smell is and why it's a problem, and you might even do this automatically with a tool called CodeScene, or you might be using CodeScene, right? So it actually helps you detect code smells. It's like, hey, somebody's doing bumpy road, cyclomatic complexity in this, blah, 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 blah. Is there a demo? Is there a demo? Where's the demo? There's a demo, right? Yeah, test it live. There's a demo. Is there a demo? Yes. Yeah, there's a demo. Right, so what happens is no, stop. What you want to do in CodeScene, for example, is, yes, I know. No, I don't want to. Just go away. If you go to hotspots or hotspot code health, you'll immediately encounter things that are problematic. And usually when you touch something in this file, you'll get a really angry message that, hey, this file has already been low health. Now the change you made it worse. Right? So this, for example, tells you, okay, how many people are authors of this file? Is the author of this file still in the company? Was there brain drain? And then there's rule violations. Okay, there's a brain method. Okay, so this method is very brainy. It does too many things. It has too many lines of code. There's bumpy road. Again, bumpy road is that thing, you remember? Indentation. Like this is like 1, 2, 3, 4. Boom, boom, boom. And then the same thing here. Going in. And then there's logic. And this is my favorite. Boom, boom, boom. For if. This is bumpy road. But deep nested complexity. But really, they're just putting together a combination of code smells, like a large method, complex method, it's like cyclomatic complexity, and then just basically automating what I just asked you. But this is easy to automate, like easy to learn as a skill. Just like learn, if you read this file, expose the code smells. Because when you know the code smells, you can find them here, and the code smell documentation will tell you which refactoring treatment, which recipe to follow, and you can just follow it robotically, is the best one. And then once you do that, you will notice that even though you didn't change the functionality of the code, you have reduced the amount of code that you need to read, and is actually much easier to understand, and adding a new feature is much simpler. As a hint, the code smells pertaining to this is that there is a interface problem. There are two things being changed for two separate rules. There is a problem of responsibility. This update quality method seems to be doing too many things. And there's a problem with nested conditionals. It's very easy. It's very difficult to figure out which conditionals are related because they are part of a business requirement, right? These are the business requirements. And which conditionals are just nested together because that's how the author, the developer, decided to logically group them to minimize, to maybe make it seemingly more efficient. That's the sort of premature optimization. Anyway, let me know what you think. You can find this on the Gilded Rose Refactoring Kata GitHub repository by Emily Bach. But I know that she is not the original author. The Gilded Rose Kata actually had a different author specifically for C#, because there was an additional requirement in C# that you shouldn't be touching the original implementation so that the interfaces don't have to be recompiled. So that the what was it? The Green Goblin in the shop, the Gilded Rose is the name of the auction house, the shop. When the shop is being compiled and shipped, you should be able to at least not have to recompile the interface, because then you also have to recompile all downstream applications that depend on it. So there was that extra little tidbit of requirements for how the refactoring should be done, based on what files you're allowed to change and what files you're not allowed to change, which APIs you're not allowed to change. That doesn't translate over to the other languages. So it only, if you do read C#, or if you want to learn C#, I would encourage you to try to do the kata in C#. Okay, so we did a little bit of event modeling, a little bit of refactoring. You can expect more of this on the newsletter as well. And I'll see you next Thursday again, for another live stream. If you have any questions, let me know. If you send me anything by replying to the email, by DMing me on LinkedIn, I'm very chatty and very DM friendly. We might have a conversation. I might address it on the next live stream. Thank you for watching. Thank you for watching the recording. If you're with me now, in the future, I'll let that sink in. Yeah, have a nice day. Bye-bye. I will have an outro at some point, I swear.